solving hyperbolic equations. Now, hyperbolic equations are equations where I have fractions, but the denominators of the fractions contains x values, like this one. And hyperbolic equations is just another form of writing linear, of solving linear and quadratic equations, because I'm actually going to change the hyperbolic equation into a linear or quadratic equation by just multiplying by the common denominator, the lowest common multiple of the denominators throughout the equation. Now, to find the lowest common multiple, you are looking at the times tables values of 5 and 1 for the numbers, so 5, 10, 15, and 1, 2, 3, 4, 5, and this, the lowest one that they have in common would be 5. And for the lowest common multiple of x values, you use the highest exponent. So there's a x to the power of 1, x to the power of 1, and actually here is a x to the power of 0. But the highest exponent I use for my lowest common multiple, and then I'm just going to multiply throughout by 5x. So this fraction multiplied by 5x, the 5x will cancel out, leaving me with 20. This fraction multiplied by 5x, if I can just show you what here on the side what I'm doing in my head, if I multiply by 5x, the x's will cancel out, leaving me with 6 times 5, which is 30. And then 1 times 5x is just 5x. So minus 10 is equal to 5x. That means if I divide by 5 both sides, that x is equal to minus 2. Can you see? I can write it this way around or the other way around. Not really going to make a difference. If x is equal to minus 2 will be equal to x, same thing. So say for instance I have now 3 over x minus 1 plus 4 is equal to 21 over x plus 1. Now, although if they gave it actually to me like this, I fill in the brackets already by habit. I'm just going to show you first. This, although there's a x and there's a x, this is an expression which is one term, and this is an expression which is one term. So that's why automatically, if you have expressions underneath brackets and you're going to either cancel out or multiply with a common denominator or anything, go and put brackets around all the expressions, like one denominator where there's pluses and minuses that separates different terms is you see as one expression. And I am then going to multiply with the x minus 1 throughout and with the x plus 1 throughout. This is like having 2 and 3 underneath. Then I multiply with 6 because 2 and 3 doesn't have any common multiples, or is not a common multiple. They or totally different numbers, like 6 and 12 have a common multiple 12, which 12 is part of, but 2 and 3 is completely different numbers, and I can't find a common multiple, so then I just multiply with 2 and multiply with 3 to get my common multiple, which will be 6 then. So that's what I'm going to do here. So I'm multiplying with x minus 1, x plus 1. Now again, you can think for yourself, if I multiply this here, I actually multiply it at the top of every fraction. So if I multiply this here, what's going to happen? The x minus 1s will cancel out, leaving me with the x plus 1. Here, if I multiply this, it's just going to be x minus 1, x plus 1. And here, if I multiply this there at the top, can you see that the x plus 1s will cancel out, and I will have 21x minus 1. If you can't see this that I did here just now, another trick that you might want to use is to actually go and expand these fractions a little bit, like this, with space to multiply. So I write the same equation, just a bit expanded so that there's space, can you see? And then what I'm going to do is I'm going to multiply with x minus 1 throughout to get rid of this one. So you see I multiply every term with x minus 1, and I'm also going to multiply with x plus 1 to get rid of that fraction. There. And then I just cancel out the denominators and numerators that are the same. So I can cancel that out, and then you write what's left. So I have 3x plus 1 plus 4x minus 1x plus 1 is equal to 21x minus 1. And this step is what I actually just did in my head for the previous example. Is I got the same answer. I did exactly this in my head. And then I'm just going to multiply this out. Can you see you have a linear equation? No, it's not linear because there is a square. So I'm just going to multiply this out first. Let me just multiply out these brackets before I multiply in the 4. Now I know, can you see this is difference of squares, so this is going to be x squared minus 1. But you can go and say x times x is x squared, x times 1 is x minus x, and then the x minus x will cancel out, and minus 1 times plus 1 is minus 1. And this is 21x minus 21. Now since I see this is going to become a quadratic equation, I'm going to in the next step multiply this out and take these two terms over, because for quadratic equations I want everything on one side. So I have 3x plus 3. I'm going to multiply this in 4x squared minus 4. I'm going to take this over, minus 21x plus 21, and then I have 0. And now I will just simplify this a little bit. There's a 4x squared term. Then there's a 3x minus 21x, which becomes minus 18x. And then there's a 3 minus 4, which is minus 1 plus 21. So it's plus 20 is equal to 0. I just add all of the like terms together. And now because my space is a bit limited, I'm just going to rewrite this equation here on top so that I can continue there. I have 4x squared minus 18x plus 20 is equal to 0. And now I have a quadratic equation which I can solve quite easily. Unfortunately, I can't take out a 4 here because 4 doesn't go into 18. So I can either do advanced trinomials, but that might or might not work. So I'm rather going to do the quadratic equation. Minus b plus or minus the root of b squared minus 4ac over 2a. And then if you still struggle with the complicated substitution in a difficult equation, it might be worth just going to write for yourself 4 minus 18, 20. So then I have minus b is minus 18, and write both minuses, the minus from the equation and the minus from b, plus minus the root of b squared, which is minus 18 squared, minus 4a is 4 and c is 20 over 2a and 2 is 4. And now I'm just going to literally feed this into my calculator. I actually want you to still see the equation and the calculator. So what I would do is first put seems it's going to be a bit difficult. First put the fraction sign, then I have minus 18 plus, I first just do the plus, root of minus 18 squared. No, what's happening here? Minus 18 squared, minus 4 and c is 20 over 2 times 4, like that. So I feed exactly what stands here into the calculator like that. And then I just move my cursor to the end, although I don't think that's really going to make a difference. And I press equal. Now this gives me 5 over 2, which I would rather write as 2.5, or you can leave it 5 over 2 or 2.5, or x is equal to, now for the second value I don't need to feed in everything again, I can just use my cursor and change the plus to a minus, and then I get 2. So x is equal to 2.5 or x is equal to 2. Okay, now I'm going to do an even more difficult example where there is 3 different things. Let's just get you on the board again. Okay, where there's 3 different numerators. I have x plus 1, oh no, this one also has 2 numerators. X plus 1, 3 over x minus 2 is equal to 1 over x plus 1. And then I'm going to multiply throughout with x plus 1, x minus 2. Now you can go and expand it again and then write x plus 1, x minus 2 at every term and then see what can cancel out. But can you see if I put x plus 1, x minus 2 here, the x plus 1 will cancel out and I will have the x minus 2 still at the top with that one. And here the x minus 2's will cancel out, and I will have the 3 and the x plus 1 there. And here the x plus 1's will cancel out, leaving me with 1 times x minus 2, like that. If you are still a bit shaky on this step, pause the video, go and multiply it out slowly for yourself and see if you get to this same thing than I do. Then I'm going to multiply out these 2 brackets, giving me, and I can see this is difference of squares, so it's going to become x squared minus 4, because if I take this and factorize it, it's going to become that. So the product of this should be that. Minus 3x minus 3 is equal to x minus 2. And now I gather everything on one side because I have a quadratic equation. So I have x squared minus 3x. I first write all of the x squareds, then I write all of the x's. So there's a x, there's a x, it's going to become negative x. Then I write all of the numbers. Here's a minus 4, there's a minus 3, and there's a minus 2 that's going to become a plus 2, is equal to 0. And now I have x squared minus 4x, this is minus 7 plus 2 minus 5 is equal to 0. And this is quite a simple x minus 5, x plus 5, x plus 1. Factorizing x squared minus 5x plus 1x gives me that, minus 5. Or you can follow the steps. Find the factors of this number, 5, 1. The factors that I subtract to get 4 is 5 and 1. And then I fill in the factors and the x's. And then I follow my plus minus rules. The signs are different. The bigger one is negative. So 5 must be negative. 1 must be positive. And then after I factorized this, I can now see that x is equal to 5 or x is equal to minus 1. So there I have two values of x, which solves these equations. And it might be worthwhile to also, from time to time, when you've done a problem and you get your answers, go and check if I substitute 5 into all of these x values in the equation, are these two sides equal to one another? And if I go and substitute minus 1 into all of the x values in the top equation, are the two top sides equal? Just to check for yourself and to get comfortable with procedures of mathematics and to do that extra bit of exercise also.